Woohoo! Welcome back. Tonight we're going to be working with trigonometric integrals. And this is part 2 of the video where we're attempting to use all the formulas. Oh my goodness, it's a lot of formulas. The good news is most of the formulas you're going to use are the same formulas over and over and over again. There are a few that show up most of the time and then a few that show up, kind of on the edges. Believe it or not, we're going to pick up right where we were before, and I'm going to talk to you about some strategy. And what is the strategy? Well, the strategy with trigonometric integrals is that U substitutions are really easy. You may not like them, but you can practice them and they get pretty straightforward. And so we're generally going to try to do U substitutions. We do not want to go here or here with the half angle and double angle and all the addition and subtraction and all that stuff. We want to try to avoid that. We like this and then these, the basic derivatives. So if we can, that's what we're going to try to do. So that's really my first strategy, is try to make a U substitution. Now, sometimes that's easier said than done, because I got cosines and sines a-popping everywhere. And so how do we decide which one to make U and which one to make du? And the answer is you want your fingers crossed, fingers totally crossed. You're hoping that there's an odd number of something. Why is that? Well, because of the Pythagorean theorem, cosine squared can be changed into 1 minus sine squared. Sine squared can be changed into 1 minus cosine squared. So squareds can be swapped around, but in order to get that du, I need a single cosine or a single sine sitting by itself. Do you see a single cosine? I do. It's very exciting, right? So look here, I've got 3 cosines. So I'm going to break this up as a cosine squared, and then a sine squared, and then a little extra cosine and a dx, right? So the cosine cubed, I'm going to borrow one of those cosines, and that's going to be my du. But then what do I do with these? Well, again, if this is my du, then I want to set up my u to be sine, right? That'll be du, that's cosine. So that means the cosine squared has to switch over to sine. How do I do that? Well, anytime I see a cosine squared, I really have a 1 minus sine squared. And this is how we manipulate that Pythagorean theorem so that we can get all cosines or all sines, whichever we need. Okay, so this is getting messy, but basically I've got a 1 times all of these. So this will be 1 times sine squared x cosine x dx. And then I've also got sine squared, so sine to the 4th. I know, you're getting... Square Bear is so excited. Not only squares, but fourths. This is like the best day for Square. And we're going to say, no, you can't eat them. And he's, of course, very hungry and feeling kind of sad. And like he'd like a little smackerel of something squared. Okay. So in this first one, u is going to be sine. And du is going to be cosine dx. Here, u is also going to be sine. Isn't this nice? It works out in both cases. Sorry, let me put the sticks in for the u's. So we're going to use the same approach for both halves of this integral. So it's not a dun-dun-da. It's like a ta-da. Okay, come here. I know. He's going to sneak up on him. He's there to protect you from the scary math, which is kind of my job too, I guess. Okay, so let's see if we can make this transition. So in the first integral, I think I've got u squared du. And in the second integral, I've got u to the 4th du. So far, so good? Okay. So then I think I've got u cubed over 3 minus u to the 5th over 5. And then I've got a bunch of integration. It's indefinite, so I'm going to add on that c. Again, if you would like separate c's for each of your integrals, go for it. It should, by the time you're done, you should have a single constant. But if you want to go through many revisions, C1, C2, and then this is main C or this is C3, that is fine. Okay, what do we have to do still? We have to transition back. The u's are the same substitution. So I've got sine cubed x over 3 minus sine to the 5th of x over 5 plus c, and we're done. Oh, and you can't see it. Now we're done. Woohoo! Box that bad boy. So what did we do? We're using finding odd numbers to set up a convenient u and du. That's going to be my approach. Whenever I can do that, that's what I want to do. Okay, so having said that, what am I now going to point out? Well, I'm going to point out that I have lost the notes. There we go. It doesn't always work the way we want it to, unfortunately. So are you guys ready? Very sad. Dun, dun, dun. But Square Bear's excited because it's cosine squared. And that's awesome, right? And immediately we think, great, cosine squared. That's 1 minus sine squared. Awesome blossom. But the problem is if all we have is a cosine squared, we don't have a u and a du. Right? We've got cosine times cosine. Cosine is not its own derivative. And if we split it up as cosine times cosine, we can't make a sine out of just a cosine. Or can we? Okay, so let's go back. Remember I told you that mostly we're going to use a couple formulas, and then every now and again we're going to use these really unusual formulas. If you took trig, you were probably like, will I ever see this again? And the answer is, unfortunately, yes. Second down from the Pythagorean squares, these cosine squared plus sine squared equals 1, we've got these related ones where if we've got cosine squared, we can convert it to a plain cosine. Now, is it perfect? No, we're going to bring in a 1/2. It's got 2 terms, but it brings us from a cosine squared down to just a cosine that we can integrate. So again, we can't integrate cosine squared. Could we integrate cosine cubed? Absolutely. Could we integrate cosine to the 5th, to the 111th? Yes. If it's odd, we're golden. If it's even, we're stuck. So we're going to use this half angle formula. So the integral of cosine squared of x dx is equal to the integral of 1/2 times the quantity 1 plus cosine of 2x dx. Now, since we're doing just a substitution of 2 equal or equivalent expressions, we don't have to change to u. This is not a u substitution. This is just a straight x substitution. So x stays x, it's all good. I'm going to give myself a little bit more room. I'm going to move the 1/2 out, and I've got 1 plus cosine of 2x dx. Now, my question for you is, do you feel comfortable integrating this without a u substitution? So let me show you what I mean. This is what I believe the integral is. Okay, so I got 1/2 on the outside. The 1 dx moves up to x. Cosine comes up to sine. There's a c. at the end, right? But you'll notice that I drew the sine of 2x up top. Do you guys know what's missing? It's a lot like with the power rule. This actually needs to be over 2. Why is that? Why is that? So I'm going to come down here. I'm going to say y. What is the derivative? Oops. D dx of sine of 2x over 2, right? Now we have to use the chain rule. So we do the outside, it's going to be cosine of 2x times the derivative of 2x, right? And that's going to be the cosine of 2x times 2. So as long as it's over 2, these two cancel, and I get just the cosine of 2x. So when I integrate cosine of 2x, I get sine of 2x over 2. The same way you do with the power rule. And so we end up with this 1/2 that comes through and gets that, and it becomes 4. So that's our final answer. Again, what I just said, maybe you're thinking, I don't know. I'm not sure. I don't like that. Reach out to me, talk to the tutors. You know, let's work through it. Let's build up your skills so you feel really confident with integration. Because being able to go derivatives, integrals, really important. Okay, you guys ready? We're gonna go really weird now. I don't even have the heart to say dun dun dun. I'm just gonna say, okay guys, let's do it. We're all together, we can do it, right? Everyone get a buddy. So, notice that my hint is massive. That never bodes well. Okay, so now we're talking about, well, this is Pythagorean right there. It's up with these guys. Tangent squared, secant squared. But I'm also talking about integrals of tangent. Now, if you were, if you feel more comfortable with cosine and sine, you can actually integrate this yet. You know, you can work this through. If you do a u substitution with sine and cosine, you could show yourself that this is true. But I'm just going to go ahead and use it as a fact. So those are our 2 facts we're going to use. So if someone says use these facts, then we use them. So we've got tangent cubed. Okay. And we've also got, so I told you the tangent squared is secant squared minus 1. And I also told you that the integral of tangent is this. So with those 2 hints, what do you think we're going to do? Well, the first thing I'm going to do is I'm going to split this up into tangent squared times tangent, just like we did with the sine and the cosine earlier. Okay. Square Bear's all ears because I drew him that way. Tangent squared becomes secant squared minus 1. Okay. And then I've got tangent, oh, left off my x there. Sorry about that. Dx. Okay, so then I've got secant squared x times tangent x, right? Dx minus integral of 1 times tangent x dx. Now you see why I gave you this second hint. The second hint says the integral of tangent is the natural log of the absolute value secant plus c. So we've got this one done. This is part of our trigonometric palooza. So the question is, what do we do here? How do we integrate that? Now, a lot of people might think, oh, is it just like sines and cosines? We got squared and a plain one, and then we just do a u substitution. And the answer is kind of. But I want to point out the derivative of tangent is secant squared. So that's why you want to have this, a sheet like this, write up a sheet of all of the facts you know about trigonometry, or just copy this one down, or, you know, hopefully I've given it to you in class. And have it by you so that while you're looking at these things, you go, oh, wait a minute. This is the derivative of this. So if I set up a u to be tangent x, then my du is actually secant squared x dx. So it's kind of backwards of what we were expecting from sine and cosine. So just make sure you've got those you know, the sheet, the information sheet there. It helps to keep track of what's going on. And again, I do want to say, again, this stuff is not easy. This stuff, these kind of problems are the kind of problems that even professors look at and we go, oh, shoot, what do we do now? Because it's easy to forget. And a lot of it is just practice and familiarity. So if you get stuck, reach out, ask for help, ask for suggestions. Okay, so I think here I've got u du. Now this one, I already know this is going to be minus natural log of secant of x, and then we've got that plus c at the end. Now, some people are going to say, wait a minute, shouldn't it be the minus c? If you would like. It is a constant. Constant means it could be anything, and if it's the opposite of a constant, that could also be anything. So it's up to you how you want to keep track of it. The integral of u du is u squared over 2. And again, normally plus c, but I've already got that. And then what was the u? The u was tangent. So I've got 1/2 tangent squared x minus natural log of secant, the absolute value secant, plus c. What do you guys think? I know, it's a lot. Please take lots of breaks. I've got one more I want to show you. And it might be a good time to take a break because I'm going to put this into this video, but this is a really different one. So you guys ready? Feel free to pause it. Go get a snack, go get a drink. I'm going to hydrate a little myself. Helpful hint. If water tastes like the best thing you've ever had, you're not drinking enough. Water should taste good, but if you're having that moment where you're like, oh my gosh, water, run with it. Drink lots. Drink lots and lots of water. Okay, make sure you stay hydrated, especially when you're doing math. I mean, not too much water. You know what I mean. Okay, you guys ready? Okay, we're going to do it. Square bears here. Pterodactyls here. It's okay. We got your back. We're going to do it. And a very gentle dun, dun, dun. Why is this one different? The two arguments of sine and cosine are different. If they matched, if it was sine of 4x and cosine of 4x, we could do a u substitution, easy peasy. But if these don't match, we can't use a u substitution. Okay. So what's the hint? The hint is we're going to go not into the main part of the list, but this kind of a little bit intimidating part of the list. If you have sine of one angle times cosine of another angle, you can actually change it to sine of something and sine of something. So we're going to be able to approach this. If you have a sine of one and a sine of another, so two sines, different angles, you can change it to cosines. And if you've got two cosines, you can change it to cosines. Okay? So this is it. This is the one we're going to be working with. So sine of 4x times cosine of 5x following this is 1/2 times sine of 4x minus 5x plus sine of 4x plus 5x. I kind of ran out of room. Sorry about that. So I've got 1/2 sine of the opposite of x plus sine of 9x. Now, personally, I'm not going to worry about the minus. There are ways to get around it, and we can talk about it. Basically, sine of the opposite of x, if I had switched this around and put 5x first, yeah, there are ways to play with this, but don't sweat this right now, okay? So I've got my new integral. One half sine of the opposite of x plus sine of 9x dx, right? Now, I haven't done a u substitution. This is a straight swap with x's. So if I had limits, if this were a definite integral, I wouldn't need to change them. These are equivalent expressions. So this is going to be 1/2 the integral of sine of the opposite of x dx plus 1/2 the integral of sine of 9x dx. The integral of sine is going to be cosine. Now, there is the opposite of x here. So what's going to happen is sine, when you integrate, goes to the opposite of cosine. But you have to divide by the derivative there, like we did in the last problem. And so the minuses are actually going to cancel each other out, believe it or not. Okay, over here, I've got 1/2. In the same way, this is going to be the opposite of cosine of 9x. But I have to divide by 9 because you know that the chain rule, plus c. So this is going to be cosine of the opposite of x all over 2. Those minuses cancel. This is going to, oh, sorry about that. I saw the plus and I wrote down the plus. It's actually going to be minus cosine of 9x all over 18 plus c. What do you think? So far, so good? Okay. Now, what else could we do? Oh, that's the worst drawing I've ever drawn. So if this is the angle theta and this is the angle the opposite of theta, tell me about cosine. If you go up versus if you go down, notice that because of the way that the angles are set up, because of the way the unit circle is set up, and because of the fact that cosine is the x coordinate. Notice that cosine of the opposite of an angle is equal to cosine of an angle. Those of you who haven't taken trig, this is something that you might not have gone through before. But if you put in the opposite of an angle, you go the other way versus the front way, because x on the unit circle represents cosine, you end up with the same value. So you could actually replace this with cosine of x. Now, what if it were sine? Well, sine of the opposite, because you go down instead of going up, that means that when you have sine of the opposite of an angle, you get the opposite value. So we get the opposite of sine of x. Do I expect you to make translations like that? No. This is perfectly fine as it is. You can leave it like this. I believe WebAssign will accept it like this. But if you come across problems like that, let's talk about it. We can work through it and work on it together. Okay? We did it. We got to the end of this one. Now, I really, really want you to stop here. I want you to do the homework. Do all the homework from this chapter that I've assigned so far. Do not go on to the next section until you've got most of it done, because the next section is going to ask you to do something that's going to look very similar, but is going to be really different. And so I want you to set this all right now and do this. Take your time, learn it, ask lots of questions. And then when you feel like this is really solid, go ahead and go on to the next stuff. Okay? I'm going to see you in the next video. Until then, please ask lots of questions. Please take very good care of yourselves. Please make sure that you know that I think you're amazing and awesome, and go out and tell someone else that they're amazing and awesome, because I'm sure you've got some amazing and awesome people in your life too. And touch some grass, get out, jump, play, sing, dance, play video games, but stay a little bit further away. Make your eyes focus at a slightly different distance. That's really very helpful. If you stare at a screen at the same distance for too long, it's not good for your eyes. So give your eyes something different to look at. And, math on and woohoo.